And find number 2 and number 4. Okay, so number 2 is multiplying by the same thing each time. Can you tell it's multiplying by 3? Do you see the 3? Okay, so we write R equals 3. Remember, when they're geometric, the growth is R, and when they're arithmetic, the growth is D. Okay, now this is kind of a hard question. If the growth is times 3, what would term 0 be? Almost. So close. Yeah. You were so close. Okay, so you need to put this on the bottom, not the top. But wonderful. Okay, so term 0 equals -2/3. I'm going to leave it -2/3 and not find the decimal because it's a repeating decimal and it's gross and it won't ever come out perfectly right if I make it a decimal. Okay, the equation looks a little different. Instead of mx plus b, it's ab to the x. So a is term 0, b is the multiplier, and then x is n, because that's what we write in sequences. And we're going to be using this all chapter. This is what chapter 8 is about, y equals ab to the x. And it asked us to find the 11th term. So we plug in 11. Oh, my calculator is about to die. It's been telling me that all morning. And I'm assuming this is going to be a big number. Yeah. -118,098. Okay, any questions about number 2? We did that a long time ago in chapter 5. It's just that we use it a lot in chapter 8, so I wanted to make sure we reviewed it. Okay, now number 4. Can you guys tell from the list what's a super easy one that we know we can divide by? 100. Beautiful. 3 times the square root of 100 times the square root of 2. Great job on that. 3 times 10 times the square root of 2 is 30 square root 2. Okay, looks like we're done with the packet. You can put the packet away. Okay, here's our agenda. We're going to work on exponentials again today. So remember what we did on Friday, those curves with the asymptote? That's what we're doing today. We're going to do table, graph, and equation, and also situation. Homework tonight is 25 through 31, skip 30. And this is my joke, except for it's kind of sad. It says parallel lines have a lot in common, but they never meet, ever. Which you might think is sad, but every other pair of lines meets once and then drifts apart forever, which is pretty sad too. Wow, what a depressing joke for the day. Okay, but wait, what about infinite solutions? Those get to stay together forever. We should have put that on there to cheer us up. I didn't want to do that. I didn't want to hit that button. I wanted to hit this button. Can't believe we're in chapter 8 already. Okay, let's look at some of the connections between the multiple representations of an exponential function. Arnold dropped the ball during a bouncing ball activity and recorded its height in a table. Part of his table is shown at right. What was the rebound ratio of his ball? From which height did he drop the ball? Write an equation to represent his data. Okay, so hopefully you guys already wrote this down. And when they ask what the rebound ratio of the ball is, they're asking, what do I multiply by this to get this? Okay, and for the multiplier, for when it's not a sequence, we use b. So right here, if you guys could put y equals ab to the x, and this is multiplied by some number b to get that. And then it's going to be the same to get that. Okay, so we're going to say 84.5 times b equals 67.6. Okay, how do I get b by itself? Divide, right? Okay, so let's just check to make sure that this makes sense. 84.5 times 0.8. Yep. Times 0.8. Yep. Close enough. It's rounded. Okay, now if I multiply by 0.8 to go down the table, what do I do to go back up the table? Divide. Okay, so I'm going to go divide by 0.8. Divide by 0.8. So 84.5 divide by 0.8. We're just going to round this to the 10th. So we're going to put 105.6. And then divide by 0.8 again to go up. And we're just going to round this to 132. That means that A is 132. And our equation is y equals 132 times 0.8 to the x. Okay, before we move on, are there any questions about where I got any of the numbers from or how I did anything? So remember, multiplying goes down the table, dividing goes back up the table. Is this easier than triangles? No? Yes? I like it. Okay, now let's look at B. A major technology company, Expo Grow, is growing incredibly fast. The latest prospectus, a report on the company, said that so far the number of employees Y could be modeled with the equation Y equals 3 times 4 to the X, where X represents the number of years since the company was founded. How many people founded the company? How can the growth of this company be described? Okay, so does it make sense to you guys that A is 3 and B is 4? Are you guys okay with that? A is 3, B is 4. Okay, what that means is they started with 3 employees. 3 is okay. Now, what do I do to get how many employees they had in the first year? If B is 4, multiply, beautiful. So they had 12 employees in the first year, 48 employees in the second year, and then 3. Do you really do that in your head? You have a gift. You should go on America's Got Talent. So good. Hey, you guys set up C and D, please. Okay, let's read C. Computer virus is affecting the technology center in such a way that each day a certain portion of virus-free computers is infected. The number of virus-free computers is recorded in the table at right. How many computers are in the technology center? What portion of virus-free computers is infected each day? How many computers will remain virus-free at the end of the third day? Justify your answer. Oh crap, I think I accidentally answered that one. I think it's 8 computers. Oh well. Okay, so let me ask you guys some questions. What is A in this table? 27. And what does that represent in the situation? The number of computers total, because on day 0, they were all fine. Okay, now we know that 27 times something is 18. So 27B equals 18. Nice. Wait, can't be. Other way. Divide by 9, 2/3, which is gross. Okay, so what would my equation be? Y equals to the X. Okay, now I'm going to ask you a really spicy question. Are you ready for the spicy question? If 2/3 of the computers are uninfected, remain uninfected each day, what is the infection rate? Let me say, if 2/3 remain uninfected, each day. What is the infection rate? 1/3, right? So 1/3 of them are becoming infected, 2/3 of them remain uninfected. I don't know if you guys noticed on the back of your packet, there's a zombie guy. That's this type of problem right here. I like him.
April 25th, right?
He's what?
April 25th, right?
Yes.
Yeah.
Okay, as part of a major scandal, it was discovered that several statements in the Expo Grow prospectus were false. Oh no. If the company actually had 5 founders and doubles in size each year, what equation should have been printed in its report?
Uh-oh.
Right. So, okay, looking at this, what is A? 5. And what is B? What number is the word doubles? 2. So the equation should be y equals 5 times 2 to the x. I hope they don't get sued. Okay, so what we're going to do is just summarize the things that we found. So the first thing we're going to say is the general equation, y equals ab to the x. So A is the y-intercept, or it's next to the 0 in the table, either one. And B is the multiplier. The graph of it is going to have a curved shape, and it will have an asymptote. If you don't know what an asymptote is, go back and watch the video from Friday. It means that you probably weren't here Friday. If b is greater than 1, it's exponential growth and is flat along the asymptote and then goes up. One more sentence. And if b is a fraction, it's exponential decay, and it comes down and flattens out on the asymptote. This is extremely satisfying end to the notebook page. Ended like perfectly at the bottom. You like anyone else's end perfectly at the bottom? No. You guys are all paper savers. I'm not a paper saver. My stuff's just giant. Jupiter's with me though. All right, we have 2 more problems, and then I'm going to give you guys time for homework. And you might want to grab a calculator for the next two problems. Oh no, there's a minor incident where my papers got folded over. Okay. Bless you. There we go. While you're writing, I just thought of a really great word problem that could go with number 23. Something like, Mrs. Talbot has 20 squishmallows. Every year she gets 3 times more squishmallows than she had the previous year. This is going to become a dangerous amount of squishmallows. If you don't hear from Mrs. Talbot, dial 9-1 and then look for a very large pile of squishmallows. She may be underneath it. Now, Mr. Talbot, he collects vehicles. It takes a lot of vehicles, no, a lot of squishmallows to equal the value of one vehicle. So I could just go nuts, buy millions and millions of squishmallows. I actually have a new squishmallow to bring to school today, and I forgot him because it's Monday. I'm very upset about it. Anyway, okay, number 23. What is the start? Which one of these numbers is the start? 20. Beautiful. And that is also our y-intercept. Our multiplier is 3. Use your calculator to fill in the rest of the table. Or try to do it in your head. I don't know the last one. Nice. Great job. Okay, so we're gonna graph what we have here, 0, 20. 0, 20 is gonna be tough to graph. Just put it like right there. 160 is also going to be kind of tough to graph. So there's 100, so 60 would be like just a little bit higher than 20. 180 is going to be like right underneath the 200. 540 is like here-ish. 1620 is like here-ish. Okay, now be really careful. Remember, it's not going to touch the x-axis. Try to leave the time. I'm going to see if I can do it. I don't know if I can do it. I did it. So proud of myself. Okay, what is the x-intercept? That's a trick question. None. Notice, I know touchy the x-intercept or x-axis, so there's no x-intercept. Domain, does it go forever to the left and right? Yes. That means the domain is all real numbers. Range, does it go forever down? No. Does it go forever up? Yes. Okay, so that means y is greater than 0. And we say greater than because it's not going to touch 0. And the asymptote is the x-axis. Let me think of a word problem for number 24. Mrs. Talbot starts with 7 squishmallows. Mr. Talbot tells her that she can only keep 1/5 of her squishmallows each year. He would never. He is the nicest man. What is 1/5 of 7 anyway? Okay, so do you guys all agree with me that the start of this table would be 0, 7?
Yeah.
And the multiplier is 0.2. Okay, so multiply by 0.2 with your calculator. Yep. Okay, our y-intercept is 0, 7. 0, 7's right here. 1, 1.4, 2, 0.28, let's say. And then I just gotta kind of like wing it, try not to touch the x-axis. Okay, x-intercept. Trick question. None. Domain. Forever left to forever right. Range, it goes forever up from 0, but not touching 0. Asymptote. X-axis. Okay, so the question is, do you feel like if you were given kind of a simple one of these equations, could you make a table, make a graph, and describe? Okay, you guys have time for homework. If you finished anything and you want to bring it over for stamps, please do.